yeah, when I started out on the job market, like the people who came to my university to recruit, they were a lot. There were loads and loads of tiny startups that did speech recognition, and now that's not the case because they all got acquired by a few giants that were really, really big in that area. And now, it would be very hard to make a startup that does good speech recognition. It's essentially a solved problem because why would anybody pay you to do speech recognition when they can use, Microsoft or Google's API?
Mhm.
And so yeah, I guess with LLMs, possibly we're getting to a similar point where it would be hard to compete with GPT-3 because the barrier to entry to creating one of those is so huge. So like a lot of people are building solutions based on it.
Hi, everyone, and welcome to this episode of the podcast. Today, our guest is Thomas Wood, who is the director at Fast Data Science. So, Thomas has over a decade of experience with NLP and machine learning, and he's provided consulting services to a number of companies, including NHS, Tesco, and other ones as well. He additionally gives yearly talks at Oxford University, and we invited him here today to speak a little more about what he does and his views on NLP and the ML landscape. So, Thomas, thank you for joining.
Thanks for having me.
Before we get started with the actual work that you're doing, I would be very interested in knowing a bit more about your background. So, maybe if you quickly want to introduce yourself, maybe your academic background and then also professionally.
Yeah, sure. So my academic background is my I did an undergraduate degree in physics for 4 years in Durham in England, and towards the end of that course, I got quite interested in natural language processing. And machine learning wasn't necessarily such a big thing at that time. So this was in 2007. I did a master's in NLP, or well, it was called Computer Speech Text and Internet Technology, and that was when I first kind of started to kind of think about how you could get human language into computers or get computers to try to interpret or generate human language. And I really enjoyed that masters. I learned a lot of things there. So it was kind of speech synthesis, speech recognition, things like that. Um, and also just processing documents, like let's say information retrieval. So I learned about search engines, and so one of the big problems was were things like question answering. So they had a so that was the area. One of the areas that I was focusing on is you ask a question, you have a set of documents. So rather than just searching for search terms like you do on Google, you actually ask a question and you try to find the answer to that. And it's a really difficult problem, and it's an unsolved problem. Then after that, I worked in a couple of different countries. So I went to Germany for a couple of years. I went to Spain for 3 years, and I worked in small companies. And I got some experience doing NLP and things like dialogue systems and chatbots. Um, and then yeah, once yeah, after a while, when I was doing that, machine learning started to enter into the equation, and I've neural networks started to be something that people were talking about a lot. And at one point, I took a job for a couple of years in a company that I did biometrics, which was computer vision. So they when I joined that company, they were doing things like fingerprint recognition algorithms. And at that time, fingerprint recognition, everybody was using the same piece of software that was from the 90s, where somebody had written a really long bit of code in C that basically nobody ever edits or changes, and it just looks for it's programmed to look for bits of your fingerprint, like features on your fingerprint. And then they had something similar, which was face recognition, and there was the same kind of established way of doing face recognition, which was find 70 feature points on your face, and somebody would have coded a definition of an eye, a nose, and an eyebrow, and all of that into an algorithm, and that was kind of how people were doing it. And then suddenly, the availability of GPUs became something that you know had exploded, and people started to try to think about using neural networks for that. And so in that company, I was just there for a couple of years, but I joined there and it was all this hand coded thing. And by the time I left, it was neural networks everywhere for face recognition, for all of that. And that was really kind of really interesting thing to try. And so we were doing things like making face recognizers on mobiles. And then,
A quick question on that.
yeah,
Were they able to actually survive that transition in technology from the old
yeah,
hard-coded way of doing things to, okay, because
yeah.
I mean, in my experience at least, a lot of times when you have a new technology that really takes an industry by storm, a lot of the players that were previously maybe active has grown to be so large that they're not able to cope with the, let's say, change in technology, and then you have some new guy taking over. But
Yeah, I think probably some of that happened, but I don't have enough industry insight into that to really know. But definitely, yeah, there was this kind of huge change, and I think the old way of doing stuff just gradually, I don't think anybody's doing it anymore. And like 10 years ago, yeah, there would have been these hand coded algorithms that you would have to pay a lot of money to license, and companies would have invested a lot of money in developing them. And now they're kind of face recognition things on, you can download on the Play Store that, using neural network took a tiny fraction of the development time to train and are more accurate. And so, yeah, I mean, I guess. Yeah, probably anybody who didn't adapt to the new way of doing stuff wouldn't have survived very long. Yeah, I think that's the case. So and then after that, yeah, I got back into natural language processing. So I took a job in a job at a job search website where they had people uploading their CVs and searching for jobs, and this was kind of really good place to try and play doing neural networks on CVs. And so the same kind of these so the convolutional neural network, which was made for image processing, it's also been adapted for language. And there's if you use word vectors, you can basically convert any text document into something resembling an image, kind of a matrix, and you can use convolutional neural networks on it. So that's kind of something that I started doing, was using neural networks to predict someone's salary or industry, or the kind of job they're looking for. And that was kind of really good because, yeah, I also had a lot of data to play with, like very sensitive data and GDPR and all of that stuff. But it was a really good opportunity to try doing that. And then and then eventually after that, I ended up I really wanted to do my own thing, so I founded a company. But so I incorporated Fast Data Science, and I started to work as a contractor and freelancer on different projects for different companies. So I worked for Tesco on a number of things where I learned about a lot about kind of huge data sets, and working in Spark and things like that. And then and now then eventually kind of the demand got quite big, and I had people contacting me from all angles, and I had a website set up, and that was kind of attracting people from different industries who wanted me to do something for them. And so eventually I stopped working for any one company full time, or taking on engagements where somebody wanted me for 6 months or a year, and I would try to take on short term things. Um, and then eventually got to the point where the demand was so great that couldn't fulfill it myself. So that's where I am. So now I don't have any employees, but I take on freelancers for different bits of projects where that's needed. And so that's kind of the stage that I'm at in terms of scaling. So I don't have a product and I don't have employees, but I do have the kind of availability of freelancers to help me, so I can kind of get far more done than I would on my own. So that's kind of.
that's quite an interesting setup, actually. So the freelancers that you're collaborating with now, are they
Yeah.
semi-permanent in the sense that you have the same freelancers usually helping you with, well, different projects across time, or
Yeah, I will. If I find somebody good, yeah, I'll stick with them for um, different projects and different companies. Yeah, so I think, yeah, when you find somebody who it's worth working with, yeah, you work with them again. Yeah, yeah. So there are a few that are kind of recurring.
how do you usually find those kinds of people?
Initially, it was kind of on Upwork and asking, or also asking around. Yeah, now basically I have a process of finding people on Upwork, and there are certain things that I've learned that I have to look for and check for. Um, and I'll do things like check their GitHub profile and check what they've done, and you know, and check that they're not. I guess the other risk is also a freelancer if they have a day job. Let's say if they're a full-time freelancer, that's lower risk than if they're somebody with a day job who works a bit in the evening or something. Because then, when the demands of their day job get, you know, get start to overwhelm them for whatever reasons, they get busy in their day job or their master's degree or something, then you know they're not available anymore, and you get stuck. You need them to keep working on a project. So yeah, I guess possibly one solution to that in the future is actually proper full time employees. But yeah, I don't quite have the guaranteed work and stability for that yet. But it's an option in the future.
Hmm. And for how long have you been running the company at this point?
About 5 years now.
Okay, so you've been in the business then on your own for quite some time. So yeah,
Yeah.
during the time that you've been working in these different companies, so from, I mean, the period where you were not on your own but working for other companies as well, how would you say the NLP space in particular has evolved? So we talked a little bit about, let's say, fingerprints and facial recognition and how
Yeah.
those industries were really turned upside down by sort of the advent of neural nets. In the NLP space, how would you say that's evolved? During the recent sort of fast-paced development, but then also during the decade previous to that.
I think there's been a huge change because I think initially, so when I, especially when I first got into the field and I was doing my masters, there was this huge emphasis on very theoretical approaches, or the neural networks, weren't even mentioned, and machine learning was kind of a secondary concern. And I think people were viewing it a bit more as a branch of linguistics. So let's say if you had the task of processing a document, the approach was to try to come up with a parser that would and you would code all the rules. There will be people trying to code the entire rules of the English language into a parser. And I remember there were some weird things like that I learned in my course. Like one of them was they had the Chomsky's hierarchy of language, and so which is all these different levels that natural language can belong to, or like basically regular expressions is like the lowest in the hierarchy, and then you have natural language is somewhere higher up. And I remember um, you know it yeah there was this thing that we covered, which was, people thought that natural languages were in one level, and then an example was found in Swiss German, which meant, and it kind of broke this theory. And it was just this. I remember the one sentence, and it was like, yeah, we asked the children to help paint the house or something, and it was that sentence in Swiss German, and that broke, put, and so there's kind of weird things like that where people were worried about some like viewing it like physics, like particle physics or something, like finding fundamental truths, which I think is no longer the issue. Like now, there's more a focus, at least in industry, on doing something that works and actually generates money. Like there's a kind of economic drive to do things, and identifying where a language fits in the Chomsky hierarchy is not, it's not a concern at all anymore. But that, so there's time devoted to things then that is not devoted, people aren't spending time on now. Um, yeah, and I think the effort of handwriting a parser, and I remember I did it like even in some of the first companies I worked at, I was doing things like that, like making NLP pipelines and making parsers, and the parser must find where the verb is in the sentence and what's and it was a lot of like stuff done by hand where um, which is really time consuming and also is really breakable because language is so complex that there's this real diminishing returns where you spend a certain amount of time on making something like that, and then you find it doesn't work for the for a minority of cases, and you just spend more and more time fixing those small number of cases. Like like this one sentence in Swiss German, you've written a parser, and then you find a particular sentence type breaks it, or type of document or whatever, and it was just like I think we've moved completely away from trying to model natural language by somebody, with a huge brain sitting down and
Mm-hmm.
writing all the rules of how that language's grammar works, as if it was like like a Latin grammar book or something. It just doesn't work. And I think, yeah, there was. I mean, some things are the same. So I think speech recognition. So my master's, in 2007 was divided into written text and then um, speech recognition and speech synthesis. And that part, I think, hasn't had such a fundamental change because that was always numbers driven. So at that time, it was done with hidden Markov models. And now we've moved on to different kinds of neural networks like LSTMs and transformers. But the idea is the same. It's collect huge amounts of data and define a processing pipeline. So you have like a WAV file coming in, and you'd extract the frequencies and do a Fourier transform and put that through neural networks. And I think that's still not changed fundamentally, but I'm not still in that area. But I don't think that there's been such a it's been a gradual progression rather than NL in terms of text processing, it's just completely swapping over to a completely new way of thinking and doing things. Um, yeah, so that's quite interesting. I mean, like still now, like nowadays, I guess I generally keep an open mind on a project. So if if there's a way to do something, if the fastest way of doing something is manually writing a rule, then I do that. If the fastest way is machine learning, I do that. Quite often, it's something in the middle where you manually write a rule that kind of makes the task for the machine learning simpler, or like simplifies the problem space.
Mm-hmm.
Um, yeah,
Okay.
so yeah,
In terms of voice recognition or speech recognition, before the neural nets came on the scene, I take it
yeah,
that the approach was a bit different. But what would you actually do? Like, let's say you get a WAV file, and then you could still
yeah.
do a Fourier transform if that was even applicable at the time, or like if that was even if there was utility in doing that at the time. But after that, how would you actually analyze it? Is it would you try to convert it in some way to, let's say, written form, and then use the same kind of architecture that you had for text
Um,
recognition, or did you use a completely different approach? I don't know if you worked with any such companies at that time, but if you know, that would be interesting.
I didn't. I mean, I just did that stuff in my masters. I did interview at a couple of companies doing that, but I mean, yeah, the aim is to go from audio to written English. Sometimes, yeah, they will have an intermediate representation of in terms of phonemes. So there were these, that, like, there was a kind of special alphabet that they made up for American English and one for British English, where like you would write two A's and it means a certain sound, and so on, and it was like a very consistent way of representing the sounds of the language. So sometimes they would go to that mapping, and then from there to straight to the word representation. But now we definitely skip the intermediate representation. Um, yeah, and I guess so. How it works, you would have the sound coming in. You put it through fast Fourier transform with some kind of window, and you'd split it up into to bins of frequencies. I'm trying to remember exactly what they did. Yeah, it was there was this thing called Kepstrom, which is like the reverse of a spectrum, where you'd generate a spectrum of the sound, and then you'd log it, and then you'd put it through another Fourier transform again and you get something that's like um, it. It was basically, you would end up with a load of bins. Like I think it was something like 13 bins that people would use, and they represent the energy levels. And the advantage of doing this transformation was that it got rid of information that's related to the absolute pitch of your voice. So there are features of an audio file which depend on whether somebody has high or low voice naturally, and this Kepstrom transformation kind of throws away or helps to throw away some of that information and keep the relevant stuff, which is what the person is saying, the phonemes.
Mhm.
But yeah, unfortunately, I'm probably not giving the best explanation of that because it's a while since I did it.
So if we're talking about the period post neural nets, so from sort of the invention of them or when they became popularized, I think they were invented quite a long time before they became popularized. But once they reached
Yeah.
the stage for sort of being used at wide scale, how have the leading models changed? Because I think models like transformer models, if you take those as an example, they're quite recent compared to
Yeah.
feed-forward solutions. So, do you have a view on how the market has shifted since the invention, let's say, of neural nets?
Yeah, I think, I mean, yeah, they were initially this academic thing. So Jan LeCun was, the first one to use CNNs, and there was Linnet, which was, I think, in the 90s, and that was, very small, and you can run that on a single laptop and train it on a single laptop, so it's very good for playing around. Then, when I got into the field, it was just, GPUs were just starting to take off. So it was this really niche thing. And the company I was working at, we had to buy GPUs that were made for, for computer gamers. And luckily, I don't play computer games, but I had a colleague who played a lot of video games. And so he was able to help set all that stuff up and knew how to configure, to put a physical GPU. So I had to order these GPUs at huge cost, put them in the computer, and then, yeah, and then like get all the software to connect up to it. And that was a lot of very low level stuff. And then, your computer would update and the whole thing would break for like 2 days or 3 days. And if you have you're doing neural network development on a computer and you have a GPU there, um, if something breaks, your computer just the screen doesn't work at all. So it's like impossible to fix. It's really yeah, like you had to get really low level, and now you don't need to do that anymore because you can just get it on AWS. So it's more accessible, or at least like training on a single GPU is much more accessible. So that barrier to entry has gone. Anyone can just open an account. For example, on Google Colab, you can sign up, pay £15 or something, and you have a month's use of Google Colab, and you can train a neural network to do images or text processing without necessarily needing to understand about GPUs or understanding how they work or how yeah or really how the neural network itself is working. But then that lowered barrier to entry means, I mean, well, the state of the art has still moved on. So now that's what was the state of the art is now accessible to anybody. But now you have large companies with LLMs, and the LLMs can't be trained on a single GPU. No, yeah, OpenAI or Google can develop their LLM, but you can't. I mean, it will be very hard to try and do it in your own home as an amateur. So that's so the state of the art is always, what a few steps ahead of what an amateur can do on their own. And probably that's not going to change. I guess also, yeah, yeah. Now I'm thinking about what you said about the speech recognition. So when I started out on the job market, like the people who came to my university to recruit, they were a lot. There were loads and loads of tiny startups that did speech recognition, and now that's not the case because they all got acquired by a few giants that were really really big in that area. And now it would be very hard to make a startup that does good speech recognition. It's essentially a solved problem because why would anybody pay you to do speech recognition when they can use Microsoft or Google's API?
Mhm.
And so yeah, I guess with LLMs, possibly we're getting to a similar point where it would be hard to compete with GPT-3 because how the barrier to entry to creating one of those is so huge.
Mhm.
So like a lot of people are building solutions based on it, and I guess yeah. So yeah, in the last year now we've had another change, which is GPT-3, and huge numbers of a lot of the inquiries that I get on my website or from people who just want to ask me advice is around that, and it's nearly always the same kind of business idea, which is to get GPT-3 to to do the heavy lifting and then to engineer the prompt. So people are asking me to do that to get, I don't know, to query databases or to do legal advice or to generate images or generate stories or generate content or
Mhm.
like the people are using it for everything. And
Okay.
I guess also there's a lower barrier to entry. So every time something becomes accessible, the barrier to entry is lower, so the value that you add by doing something is also less. So like you can now build something really impressive that's built over GPT-3, and that would do something that kind of would have amazed people 5 years ago, and you might well have made a load of money if you had been able to do that thing 5 years ago. But now everyone's doing it, so the barrier, like there's no barrier to entry. So you probably still can't make a huge amount of money because there's just it's so easy to now build on top of it. So yeah, so I guess like it's kind of hard it kind of hard to keep ahead of the curve, and there's never really a free lunch, I guess, when things
Yes.
become, yeah.
Well, I guess just looking at, let's say, the retail websites that you can go to out there, pretty much all of them have chatbots now, for example. I mean, you didn't see
Yeah.
that just a few years ago. So I guess from your perspective, I would be curious to know whether there's been a lot of changes to the kinds of requests that you get. Like, obviously, now with GPT-3, like you have
Yeah.
very specific requests as a direct consequence, maybe, of that launch. But on a larger scale as well, has there been like a change in interest for what people are trying to do with NLP solutions?
um I guess like, yeah, the obvious one is things like when there's hype around a particular thing, so which at the moment is GPT, the GPT series, then I get huge influx of inquiries on that. I need to do some kind of trend analysis of this over time. And yeah, I guess it's more and more industries or organizations that have maybe historically been quite conservative, maybe because of data protection, and then they're starting to move forward to thinking, okay, maybe all this personal data or all these emails or whatever, we could do something with it. So at the moment, one of the projects I'm starting is for a housing regulator where like it's in a province in Canada. So everybody who buys a house in that province, a new house, gets um, gets a document, a form that they fill out that says like there was, they have to say electric fault here, or there was a scratch in, 2 inches up from the floor on the paint in this or that location, or plumbing leakage or something. And this is all free text, and they've been gathering it for decades. And now suddenly, like they're interested. Well, now that there's this impetus to build a predictive model that would identify, what kind of fault there is, and where that's going. And I've got a lot of projects like that. So like regulators and things in different countries that have always gathered that data, and in this case, yeah, it's very sensitive data, so that's probably an obstacle. And also, it's just hard to kind of get, text data is hard
Mhm.
to deal with. It's not as, yeah, it's in, and also like the toy examples that you have, when you look on NLP tutorials online or something, it's always the same examples, like news groups or something, and they
Right.
have clean data set of news groups from 5 topics, and there are similar, amounts of data in each topic. And in real life, yeah, I think a lot of the work is actually defining the problem. Is this, I guess one thing I would always do is try to simplify it down to a classification problem, or something where you're not trying to do anything too complicated with the machine learning. Maybe
Mhm.
help the machine learning out. But often, yeah, the client doesn't come to me and say, I want a text classifier that will classify into 5 categories, and here's the data. It's like
Mhm.
it's kind of a conversation back and forth, and that's kind of, I think that's a lot of the work, as well as like working out how the technology can be used to benefit the company, or yeah, to solve whatever problem they have.
Mhm. What is that interaction usually like? So, in terms of the people that approach you, are they usually
Hmm.
decision makers in these companies that don't have a strong technical background, for example, and they're not quite sure what they want? Or is it usually someone more savvy from the beginning that reaches out to you and sort of have an idea already of the problem they're trying to solve?
It could be anything, yeah. It could even be that the reaching out is that was delegated to somebody.
Yeah.
Somebody's gone, like somebody asked an you know an assistant somewhere in the company to reach out. But yeah, ideally it would be somebody as high ranking as possible, who is at least my first contact, not necessarily the day to day contact. Quite often it's somebody, yeah, it's often somebody technical, like in the CTO position, but sometimes it's somebody completely non-technical, and that's fine as well. I think, yeah, I don't necessarily need them to be technical. It's just somebody who can basically identify the priorities of the business and um, and I can fulfill the technical side. So one thing that we do, one exercise that I sometimes do at the start, is we make a list of all the problems that they've got, like all the possible things we could do with machine learning, and so we might say, you've got 10,000 documents about like defects in a home or about conveyor belt breakdowns or whatever. You know,
Mhm.
what are things we can do? Classify them, find clusters. Maybe they're completely unclassified. Maybe predict risk. Maybe predict cost. Maybe predict how long it's going to take to resolve the issue, and like rank all those things. And then like maybe that, and I would rank them, and then the client would say, okay, what's the business impact of each of these? And I would say, what's the technical effort? And then we can kind of work out and essentially do a cost benefit analysis of all of that. And um, that doesn't need the client to be the technical it doesn't need a technical person on the client side, but I think you do need, ideally, yeah, if they have some kind of IT infrastructure, you need to talk to somebody technical who would give you access to everything, and kind of that, yeah, that would be helpful. So yeah, I guess a bit of both. Yeah, probably
Right.
a business person is more important.
How do you assess what's actually possible to do with their data upfront? So I would guess that taking, for example, your the example you gave with the Canadian client, they have some form of database filled
Yeah.
with text data from maybe a decade in the past. I would
hmm
guess that it's unclear in a lot of those cases what the quality of that data actually is, like whether you can leverage that for the intended application or not. Do you have some structured way of going about assessing what you
Yeah,
can
I
do?
mean, if they can send me a sample, so I'd like normally sign NDAs after talking to them for the first time. If they can send me a sample, that's helpful. Then I can kind of go through and do, I'll put it in a Jupyter notebook and spend an hour or so and say, okay, here are the categories. This is the accuracy I could get classifying it. Um, it's not always possible to get hold of the data, so I would just try to kind of infer it. But I think if somebody tells me they have, 1,000, if yeah. So one thing I learned is also like when people contact me and it's about a startup idea. Let's say they're saying we want to make a new job search website, or that's a really common thing. I say like, okay, what data have you got? Have you got any CVs? No. Okay, that's something I can't work with that because it it's yeah, you need the data to start with. Um, and I think that's something that's often missed. Like, so I get a lot of kind of, let's say, entrepreneurs who have a new idea, and if they've not been in business they for long, or they're not, yeah, their business is just kind of in this very embryonic phase. They won't have any data that we can necessarily work with normally,
Mhm.
and so um, but if somebody is like a kind of company with national or regional, reach, and they've been in business for 10 years, they'll easily, there will always be enough. And I think it does depend on the kind of data, but documents are normally very rich in information, and so even something like 100 you could do something with. But yeah, as a rule of, if they're in the orders of thousands or even millions, yeah, there's no question that there will be something we can do, especially if they've done no NLP on it at all. Um, there's a kind of sanity check as well you can do, which is to just load the data into your laptop, and can you make a naive Bayes classifier?
Mhm.
And what would be the ROC or the accuracy of that? And if
Mhm.
and if you plot an ROC curve, you can see if your classifier is doing anything useful or if it's not delivering any value. And so if a naive Bayes classifier is able to do something useful, okay, that's a starting point. We should be able to improve on that. Um, I guess also one thing I've been thinking about is in terms of the classifier. If somebody wants, so a few times I had projects where I realized that this wasn't possible, It wasn't possible to do anything, and that would be when somebody has product descriptions and the aim is to categorize products into 1,000 or more categories, a huge number of categories. Making a any kind of machine learning classifier that classifies into 1,000 categories is very very hard. It's very different from 5 categories or something, and it's
Right.
not a linear relationship. I need to kind of work out exactly how that relationship works, but my gut feeling tells me if the ask is unrealistic, then that also doesn't that's also not necessarily going to be possible or would be very hard to do.
Mhm.
Um, yeah, so I guess one thing I'm thinking about is get to try and quantify this, like do an experiment where I work out how many is possible, or how many documents you actually need to get something useful as a rule of thumb
Mhm.
for X number of categories. Because if you're just doing two categories, yeah, you could have 50 documents of each type and you'll nearly always be sorted. But doing 10 categories, you might need 1,000.
Mhm.
Yeah, yeah. So it's kind of a bit of gut feeling, I guess.
Mhm. And when it comes to the kind of, let's say, return on investment that the company gets, is it is it usually difficult giving them the answers they want up front? Because I would guess that a lot of these companies reach out to you. They ask roughly like,
Yeah.
how much more efficient can we make this process if we introduce your AI solution? And from your perspective, I guess that would be extremely hard to give an answer to. Are there other resources that you could point
Yeah.
to? Like, let's say EY does large scale studies across industries for like how much automation efficiency on average you've gotten from adopting these kinds of AI technologies within these fields. Is that something you usually provide clients, or are they more accepting of the fact that there is a lot of inherent risk, perhaps, in the return from these kinds of technologies?
I try to give an idea of what we would expect, but often it's kind of going from no data science at all, or no NLP at all, to having NLP, and so there's always going to be some ROI there. If it was different, like I was coming in and they'd had somebody doing NLP before, and then they're saying, "Can you improve on this?" That's a little bit trickier. I'd have to look and see what had been done, but I would say when there's when there was the date, 1,000 CVs or error reports or whatever, and they were doing nothing with it, and now they're going to doing something with it. ROI is always going to be there, and I guess you can imagine the ROI because you can think, okay, how much manual work do we have to do, and you can kind of work it out. Okay, if we had an AI to do this, we could move this manual labor from this area to something else, and that's something that they can work out. Um, so yeah, so I mean, another one I've got is this clinical trials categorizer. So that's kind of one where you have So I've got a few projects where there's pharmaceutical companies and they have large numbers of 100-page PDFs, and they want to try to get information out of those, like how many subjects there are in a trial, and that's something where it's quite laborious to read through a clinical trial document and say, okay, like there are 58 people participating in this trial. This trial has 2,000 people, and like so I've written an NLP algorithm to do that, and that's if somebody uses that, then um, it's maybe they're saving themselves X many minutes per document they have to review. Um, yeah,
One question that I have in particular when it comes to those kinds of applications is also the regulatory landscape. I don't know
yeah,
if the regulation is catching up in some sense. I think Europe is sort of spearheading the regulatory development, to put it that way. Um, is that something that you have to take very actively into account when working with those companies? Like, let's say you're building some classification model um, to stay compliant with, for example, discriminatory laws, stuff like that. Is that something that actively affects the industry, or is the regulatory landscape still at the stage where that's not a big concern for companies trying to do these kinds of solutions?
I mean, I think there have been kind of various proposals around the world, like Europe level, UK level, US, for regulating AI, but I think in there's nothing yet in force that I'm aware of. But there are things around GDPR and also yeah, just in general avoiding discrimination, and also yeah, like especially large companies have all these, this accountability where yeah, they have to be very certain that they're not discriminating. Um, Having said that, yeah, I mean, most of the time, yeah, it's. I guess the main issue is data protection rather than bias. Like bias is an issue. I guess like in a few niche cases where let's say you're granting somebody a loan and it might accidentally discriminate on the basis of or yeah, of like some protected characteristic. Um, but yeah, for most of the things, let's say like yeah, identifying if somebody's report about damage to their drywall is going to escalate to a lengthy repair or not. That's um, I would say the majority of projects, yeah, it's is not so much an issue, but like the documents that they send may have personal information or identifiable information or email addresses, dates of birth, and all of that. And so, um, one solution is to try to kind of anonymize data before you use it, but in practice, um, in what we end up doing is if it's a client with that level of protection requirements, we keep everything on their server and we don't leave their server. They create an email address and all of that inside their organization. I've temporarily become a member of their organization and work on remote desktop. And then nothing even gets downloaded to my machine. I don't screenshot anything. I don't, no information leaves leaves their system, and that's yeah. And then so to do that, yeah, I'd start the project and like I have a checklist of things I would ask their IT to set me up with, like GitHub repository, and what one option is, for example, there's Azure ML. So if it's a company that uses let's say Outlook and Microsoft products, then there's a machine learning environment that's in that you can add to that package. So their IT will just create an Azure ML environment, and that lets me run Jupyter notebooks, train models, deploy models, and do everything within that environment. And it's not leaving their server. It's not leaving their location if they're in Europe or England or wherever.
Right. So even the servers that would run the, let's say, the training would also be located within the company in that case, or
Yeah, yeah, yeah,
okay. Can most of the infrastructures handle that? So, like, my idea or my understanding going into the call is there's a lot of cloud-based solutions, and generally you would outsource
yeah.
sort of the training of NLP models to those. I don't
Mm.
know how computationally demanding the general application that you build is for a company, but if you have a company that doesn't focus on very computationally intensive tasks, I would imagine that that's an issue when it comes to training these models.
Yeah, I think even if they don't focus on computationally intensive tasks, they would have some kind of internal Outlook, for example. So that would if the employees are using Outlook to set meetings with each other, then they have a Microsoft, they'll have an Azure account, and it's just a few clicks for their IT person to create an Azure ML, even if they know nothing about how it works. Um, so I've not really encountered that. Like even organizations where they have nobody technical at all, they would normally, or they might be using G Suite. Like that's very simple to set up. And if they're using G Suite, then there's Google Cloud Console, and I just say, please, add me to your corporation's Google account, and or I say, please, can you create a Google Cloud instance, and they'll do that. I don't need to have permission to do that, and I could say, okay, I need a budget of $500 a month. Just please put a budget cap so I don't accidentally go over it, and like I work out how much anything that's running on their cloud account is going to cost, and I can let them still be the administrators of it, and I just work in that account. That's kind of yeah, a safer way to do it. I feel a lot safer doing it that way. If I was doing it on my laptop, then I would have to worry about, have I deleted this data, or all these kind of liabilities, and if it stays on their system, then that's one thing that I don't have to worry about.
Mhm. And do you generally collaborate with companies have that are sizable enough to always go with that solution, or do you also implement things on your own? Well, maybe not your own machine for training and so forth, but at least locally, like running it toward a web service, for example.
Um, I do sometimes, yeah. Like sometimes if there's also normally a bit of friction in their IT. Like let's say their IT department will take a while to set things up. That's and sign things, and because their IT is really a department where they have authority to do new things with that, like they have to go to kind of an executive level person and that person is busy and so yeah, so I'll do stuff. I'll set up my own GitHub to start the project because it will take forever to get the company to give me a GitHub perhaps, and eventually by the end of the project I would ideally aim to transfer it to their infrastructure. um, yeah, I could do it. Yeah, ideally. Also, yeah, I mean, working on my laptop is helpful as well because it forces me to keep everything small and simple. Because that's the other thing is Occam's razor. Because quite often, yeah. So sometimes I do come onto a project and they've had a machine learning or NLP person before, and they've done something really complicated. Like and the client has no idea what that person did, and they did something in neural network, and they said it was a neural network, and they wrote like a huge Python script that nobody can execute, and nobody understands what they did, and sometimes like they could have just done a naive Bayes classifier and deployed it like to on a web service. I think that's another thing that's overlooked as well is front ends. So I mean, front end is it's not really my forte. Like I get people to do it for me, but I notice when I go into a company and I see what the last like NLP or data science consultant person did, often yeah, there's no front end, there's no way of running it without being a coder. You know, and it's code that stopped working after 6 months anyway because like software updated and I guess that's part of the problem that you don't want to be going in and causing problems. You want to be going in and solving problems for them. And I think the technical knowledge is just a tiny part of it. It's like the business knowledge as well. The business understanding is like important.
Mhm.
Um, yeah.
Yeah. I see that we're starting to run up on time, so I think we should slowly bring it to a close. I think one thing that would be interesting to know as well is when it comes to the companies you're interacting with, are there any common misconceptions they have? Maybe approaching you, like the things they can do, or a lot of experiences you've had with the collaborations where maybe they've expected something that they don't get delivered, or they expect things to work in a different way. So I think the front end is one good example of that, right? You have maybe executives expecting to get an ML solution, and that more complex is always better, but that it may lead to people not being able to execute the code in a few months. Are there general missteps that companies take when they approach you and they have maybe a misconception of what the collaboration will be like?
I think no, I think normally people come with an open mind and they don't have a kind of fixed idea, and I'm willing to do whatever it is that they need that would be that would solve the problem. I think sometimes people kind of approach the problem backwards and they say I need an AI to do this, and or I need somebody to do this with GPT-3 or with neural network or something, and which is kind of putting it back to front really, like that may not be the best solution. That may not be a solution at all. It may, I want to understand first of all what the problem is that they're facing, or how it is they could, what data they have and how they could kind of extract value from it. So yeah, in general, like company with huge amounts of documents, yeah, it will be a gold mine of data, and how what they do with it, yeah, like there may be things that they've not thought of, or they may be kind of stuck, like married to an idea. So I had somebody who contacted me about the idea of making AI that would recommend, I know, some kind of medical product, and I said, well, I asked about the data, and they didn't have any data, but what they had was like a load of rules and decisions that say, okay, the person has this symptom, then go to this, so 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 what they had was the opposite of data. They had the rules already. So AI would be something that you have the data, you don't know those rules. So the AI would infer those patterns. If you don't have the data, but you do have those rules, then there's a limit. I don't. think AI in that case would deliver any value, or at least like not as I can practically implement it in practical terms. I think also there's like a disconnect between yeah maybe things that are done in academia or you know yeah so like you read academic papers and it's people doing like weird and wacky things, and I think the stuff I do is not necessarily like absolute cutting edge things that could be published in a paper. It's just what practically works, and a lot of the time, it could be a simple linear regression model or something, and I think um, yeah. So I had a project. We had a project for Tesco. Like one of the projects I worked at Tesco, it was predicting the time it takes to load a lorry with crates, and you have two types of crates, like frozen and non-frozen, and you have the location that it stops at, and like parameters configuration of the lorry, and the people before we tried any machine learning, the people um, had basically a formula that they used, which was like X minutes plus 1.5 minute per crate or something like that, and which would basically be a straight line. And when you build a machine learning model, you get exactly the same things, So sometimes, a lot of the time, people's instinct is correct as well. Like, their main instinct. Like, so if you ask somebody working in clinical trials, what it is that makes a trial expensive or high risk, they will tell you. They will always tell you the same things, the same factors, um, and so like that somebody's gut instinct is also very valuable. Sometimes they might think the AI would tell them something completely new, but really like if they know the business in an like or the industry like the back of their hand, then um then the AI will quite possibly like come out independently with a load of insights that replicate their intuition. I mean, where it gets a bit more, it will also be a bit more sophisticated. But let's say for clinical trials, so the thing that everybody agrees on that makes a trial high risk is if the trial does not have a statistical analysis plan. So if the people planning the trial haven't planned how they're going to do the statistics, and that's kind of a high risk feature that kind of swamps every other feature. So you can do everything else right, and just that one thing you do wrong, your trial will be high risk. And so if you train a machine learning model to predict that, and like people have done this kind of investigation, normally that would be what would come out because that's. But there will be other insights that come out as well. But like overall, it won't kind of unless if you've massively misunderstood how things work, um, it won't contradict massively kind of human intuition, or at least not expert intuition. Expert intuition is itself is valuable.
Perfect. For people that want to get in contact with you, maybe for projects or just to get questions answered regarding NLP, where can they reach you?
So you can reach me at my website, fastdatascience.com, or you can also find me on freelance datascientist.net.
With that, Thomas, I would thank you very much for taking the time to speak to me today. Thank you for joining.
Yeah, thanks very much for having me. Cheers.